just say a few sentences about computing in science education, and it will lead to the user interfaces and to maybe some thoughts about how the user interfaces can evolve for computation, for, so to say, narrative computations. And it can be maybe interesting for D-Wave to have a look at some technologies. Maybe you did already, but most of the technologies I will show come from US. So anyway, so we started a project about computing in science education, which was involving introducing some computer algebra system called Sage Math into our curriculum in physics and a little bit of chemistry. And Sage Math is a system which is based on Python. I have a laser here somewhere. Here, yes. Yeah, oh yeah. It's a system based on Python, which is nice thing because we have mainstream language and it can be used for mathematics too, and it's containing lots of software. So Sage is a little bit more than Python alone. Is a bunch of really 1 gigabyte of software, mathematical software, and it's a free and open source system, and it's having a ambition to be replacement for Mathematica, Maple, Magma, and most of those systems. And so what we did also introduce this. We have similar sister project. We have a leader from the Horzów School also here, our former worker, Dr. Ogaza, and we run it for guys in the school, and it's, well, my impression is that it's successful. I mean, some people like it. And what's interesting about this project, I'm not going to go into detail into this, but this we started in 2011. To experiment with the system, not to giving a software and it just lets people install everything from scratch and play around with each other computer, but giving them the web interface. It was a system called Sage Notebook, which it was a web interface to the Sage Python-based interpreter. And this was actually, we run a cluster, and it's running even right now, and we serve like 2,000 people. They created like over 13,000 documents in the system on some very old, almost provisoric cluster, which was supposedly survived 1 month or 2, and actually is running till now. This is regularly used for our physics studies and many more. So we like the idea that this people like this, that you have somewhere, you like to Google, you log in somewhere, you get your documents, you do some work, you log out. So every computer room was automatically upgraded to a working computer room for any kind of scientific computation. Well, since I was interested in these activities, I put my attention to a little bit bigger project, which was now it's financed by European communities, called Open Dream Kit. It's actually, there was a call in the European community for building a virtual research environment. So it's not education, it's just a research environment. And the mathematicians, they were very much interested, mostly the French mathematicians, but also British and the other, from other European countries and even from states, to build and research on how do the mathematicians collaborate and to give them something like a virtual research environment, whatever it means. Actually, what it means to give it a cloud service to work with and to do everything in this service, not just one thing per service. And this is quite a big project. I'm involved. I'm doing a very tiny thing in this project, and I'm just going to show you what's going on. So this part of the project I'm interested. I'm not interested in the research how the mathematicians work, but I'm interested in the tools which they are using. And of course, they base lots of those things in the Sage Math. The Sage system, if anybody used this, it looks like an educational system, but in fact it's a system which is used by mathematicians, by pure mathematicians, to do some combinatorics. And this is a main developer as a field, or research field. And they switched recently to Jupyter Notebook. And Jupyter Notebook, this is the definition, was the Jupyter Notebook from the website. It's a kind of new notebook system. It looks like more or less like this. So you have something like you have, as in Sage Notebook, you have a code, you have some rich text and rich output, and possibly some widgets which are barely visible, but there are some sliders you can play around with some formula. So it's very similar to this what you built. I mean, of course, everybody is building now web interface, but the thing is about the Jupyter, it gives you another level, because in Jupyter you have to create this widget. You just say, give me widget of integers from 1 to 12, and you got the JavaScript code injected, and this widget is by WebSockets connected to your interpreter. And the interpreter in this case, it can be Sage Math kernel, can be Python, can be MATLAB, and there's in fact about 20 or 30 languages which have the native kernels. So the computational kernel oh, this is a great slide. So this is like you have the browser, you have the notebook system, which is this what you interact with. Then you have a HTTP and WebSockets secure connection. This is a notebook server which runs somehow runs using the queuing, using the next internet connection. You run the kernel somewhere. It does not need to run the kernel in the same place where is the server actually. This is actually what we do with GPU computing. And the kernel is any kind of interpreted language you can imagine. So this is, for example, Bash kernel. And this notebook is taking care about writing the files. There is a bunch of libraries if implemented for any language. Mostly Python is the first language, a first class member of this kernel family, but this is how it works. So you have these widgets and all the kinds of fancy things. So this interface is shown as for programming computer. It would be also possible to program directly in the Jupyter, because it's everything you have. And then you have probably more flexibility about how to analyze the data, because you have everything in one place. So this is, I have some demos, I promised to be in 10 minutes. So this is, what we do actually, we do the two things in this Jupyter. We develop some 3D graphical systems, which is based on, now I have big screen, that's interesting. Yeah? Okay, so this is like, so this was interesting that, so you have like Lorentz attractor system. Oh, that doesn't work before I have to restart the kernel. I've got the kernel once more just to make sure it works. So I have a 3D widget which is displaying me a cloud of points, and I can run. And the funny thing is the 3D widget is on the computer on this Mac is rendered by 3JS system, right? And then I have a Python code, and which is giving me for forwarding these points as this is the three-dimensional space. I have a Lorentz system, three-dimensional nice chaotic system, and I can do this. So this is a NumPy table. This is vector Euler scheme, and I can just run the algorithm, but I can update the points. And this because this is a IPython widget, those positions of the points that are in the network, they are connected with by WebSocket with this variable in Python. So it means that anytime I update this variable, this will be sent from the server, and the server actually is a server room here in this building. But even if it's in another city, it's quite quick. So when I run it, let me run it. So those points, they evolve, and you can of course turn them around and you see. So the idea is that of course there's a bunch of simulations like this on the internet. You can have JavaScript pure solutions, but there is a general solution when you have some very general purpose widgets for displaying data which are really transferred live to this widget. So for the molecular dynamics, for dynamical system, for whatever you can imagine for quantum computers, I'm pretty sure it's the same. So you can make a widget and program this in any language for which you have the kernel. So for example in Python. So okay, so because we are a little bit out of time, so I think that's all what oh, there's maybe one slide more. So we have the interface in this Jupyter, so we can run the kernel on any other machine using this SSH tunnel. So which is very nice, because I can run the kernel, computational kernel for my notebook system, somewhere else for United States, in Germany, at home, wherever I want. And we use it particularly for running the kernels on GPU machines, because this interface server is not having any GPUs, it's not for the HPC. But I can run the GPU, the kernel on the machine with few GPUs and do the GPU computing, which we use in our group for research. So basically, that's all. Thanks.